Hey all, welcome to lesson 4. We're going to talk about metals and nonmetals. So we're going to, hopefully, I'll be able to describe the effect of periodicity on the brittleness, luster, and conductivity of matter. We'll be in the note packet, pages 11 and 12, and that's it. Nice short day here. All right, if you turn to page 11, you'll see that the title is The Periodic Table Can Be Keyed. The idea of being keyed means it's like organized in a way that you can understand a specific property. We have what we call a staircase. I think we talked about it before. It goes through the periodic table like this. It separates the nonmetals from the metals. Okay, let's talk about the metals first. They make up most of the periodic table. So most elements are metals, and they are to the left. So all of these over here, or below the staircase. And there's one exception, hydrogen. Hydrogen is an exception for a lot of things, and we'll talk about that more in a little bit. All right. They're all solids, with the exception of mercury, which is a really interesting metal. They must have, all metals must have all 4 properties. So all 4 properties of metals. First of all, the idea that metals can be hammered or molded into sheets is called malleability. So they're malleable. Second, they can be drawn or pulled into wire, so that's ductile. And they have luster, which is a beautiful color or shininess, I should say, to the metal when polished. And if you put electrons in them, electromotive potential they call it, they conduct, so they're good conductors. Allows heat and electricity to flow through them. And because of a sea of mobile valence electrons, it gives them that conductivity. All right. Just remember, why are things conductive? Because they have a sea of mobile valence electrons. They tend to lose electrons, so they like to lose electrons, and they tend to form positive ions. Now, if we take a look at the other part of the periodic table over here, let me just turn on the highlighter. This area here, I guess it doesn't come out perfect, but those are the nonmetals above the staircase, and they have certain properties too, but they're a little bit more, like they have more variety. So first of all, where are they on the periodic table? They're the right or above the staircase. They're mostly gases, but things like carbon, they're solids. There's one rare element, bromine, that at room temperature, just about, it's a liquid. Okay, they are not malleable or ductile, so you can't just roll out carbon into a wire. They're brittle usually. Think of charcoal, they shatter easily. They usually have no luster, so they lack luster. Literally, they lack luster, and they're dull. It's another word for dullness. They either don't conduct electricity or they're very poor conductors of electricity. They do like to gain an electron though. So they gain one or more electron, and that forms negative ions. They'll share these properties, that's why we think of them as nonmetals. This is like a whole group. They may have 1 or 0 properties of metal, so they might share 1. Some are semiconductors, but they don't share a lot. Metalloids, you might be able to guess, are right between it. It's these purple ones that we're talking about, right between the staircase. They have 2 properties of a metal, and they're just along the staircase between metals and nonmetals. The only exception is aluminum. Even though it's along the staircase, it's not. All right. Here's some things or questions we have based on that. Which type of element is located below or to the left of the staircase? What is the exception? All right, that's not too bad. We know what type of element is located below. We know that's metals. But there's one element far to the left, and it is not a metal, and that's hydrogen. Hydrogen is the exception. Which type of element is above and to the right of the staircase? Those are nonmetals. Which type of is located on? This is right stuff from the. It'd be better if you did this yourself, so that's good. Which of the following is not a property of a metal? Metals should not be brittle. The rest of them are all properties. They're the 4 properties. All right, try these. Helps you understand how well you understand it. Then unpause the video. You know the deal. All right, welcome back. Thanks for unpausing the video. The sample of element is shiny, good electrical conductor, does not shatter when hit with a hammer. What kind of metal? It's a metal. At least has 2 properties of it. A sample of an element is dull. That's definitely non-metal. Does not conduct electricity. Non-metal. Shatters. Non-metal. So I'm fairly safe that there's those 3 conditions for non-metal. A sample element is shiny, so that's a metal indication. Does not conduct. That's a non-metal condition. And shatters when hit with a hammer. That's a non-metal condition. So I'm going to call that a metalloid. What do metals have that allows them to conduct heat and electricity so well? They have a sea, I should call it, an ocean of mobile valence electrons. It's a phrase that you'll hear a lot, and so I need you to write that down. Try to get that in our memory banks. And that concludes our video. Thanks for watching, guys.